Hello everyone. Let's study about Huygens principle of wavefronts. It's pronounced as Huygens, but many will call us Huygens. So I'll also use the word Huygens only because it's a commonly heard word, but then actual pronunciation is Huygens. Now this tells us how does a wave propagate from one point to another point. Imagine that we have a source of light here. Whether it is a point source or an extended source, light from the source goes in all directions. So this theory tells us how does light move from one point to another point. So that's a theory basically about. To understand this, let's look at some of its points. The first point says every point on a primary wavefront acts as a secondary source of disturbance and emits secondary wavelets. Wavelets means they're like short. Wavelets are like short waves. To understand this, let's take example of a diagram as seen here. In this case, let's take a point source. The same argument could be used for extended source or point source also, but here we will take it for a point source. You learned in early classes that for a point source, the wavefronts would be spherical. Imagine that at some point of time, imagine that we take a part of the wavefront called as A dash. As given here, we take part of the wavefront called as A dash. So according to Huygens theory, it says every point on the primary wavefront acts as a secondary source of disturbance and emits secondary wavelets. So from here, if we look at few points, a point as shown here, a point as shown here, or a point shown here, if you look at few points, imagine that this wavefront theoretically consists of infinite source of disturbances, but here we have drawn only few sources as shown here. Now from these sources, secondary wavelets are given out. Now these wavelets are like short waves. It goes like this in all direction. This is what we get, like short waves. That's the first point. So first point is every point on the primary wavefront. Here this A dash is called as primary wavefront. Keep in mind that the same argument can be used for cylindrical or plane wavefront also. From here, secondary wavelets are emitted. A part of it moves forward and a part moves backward. So this part is a part which moves forward and this part moves backwards. So he himself told that we call this part is called as forward secondary wavefront, and this part is called as backward secondary wavefront. The second point here is a common tangent drawn to all these secondary wavelets forms the secondary wavefront. Here, if we draw a common tangent, then we connect them, then what we get, that would be the secondary wavefront. So in this case, B dash would be the secondary wavefront. So B dash is called as secondary wavefront. Now keep in mind that we have taken only few of the points as sources. Otherwise, if you look at every point as a source, we get a wavefront everywhere like this. We get a wavelet everywhere. If we join those points, then what we get from there would also be a sphere. So as seen here, this B dash acts like a secondary wavefront. Now this B dash in turn acts as primary for the next wavefront, which means every point on this B dash acts like a source of secondary disturbance, and every point which acts like a source would produce secondary wavelets. So a wavelet here, we get secondary wavelets everywhere. A common tangent drawn to all of this would give one more wavefront, which means for the next wavefront, this B dash acts like a primary wavefront, because of which we get one more wavefront to join them, one more wavefront which will be spherical only, that you can call as C dash C. So for C dash, B dash acts like the primary wavefront. Similarly, every source on this C dash acts like a source of disturbance and produce secondary wavelets. If we draw them, we get one more wavefront, which means the next wavefront, this C dash, we'll call this as D dash. This C dash acts as primary for the next wavefront. Similarly, this D dash is secondary wavefront for C dash, but this D dash acts as primary for the next wavefront, which means AB or A dash, which acted like a primary for B dash, was itself a secondary for some other wavefront. Let's call it as say X dash. So for X dash, A dash was a secondary wavefront. So this is the idea of secondary wavefront. Now the question is, at any given point here, how does the energy or wave move? Does the energy move along this direction or this or this? Is a question, because we know that the energy from a point source goes in all direction. To understand this, let's look at the third point in the theory. It says normal drawn to any point indicates the direction of flow of energy at that point, which means suppose at a given point here, at this point, you want to find out how does the energy propagate at this point, then what you can do is we should draw normal. Now since it is part of a sphere, normal would be its radius vector. A normal drawn from here to here, this normal would indicate direction of propagation of the energy at that point. Similarly, if we had to find how does the energy propagate from this point, again from this point draw a normal to this point. So this normal drawn from the center to that point would indicate the direction of motion of energy at that point. Now one important point to observe here is, as discussed earlier, we get something of this kind because this point will produce secondary wavelet. This part from here to here, this part is called as forward secondary wavefront, and this is called as backward secondary wavefront. But we know by experience that light moves only in one direction, the energy doesn't come back to us. So Huygens himself told that the backward secondary wavefront doesn't exist, which means he told that this part will not exist. So whatever exists would be only the forward secondary wavefront. So this part here which moves forward is called as forward secondary wavefront. So this is how the wave propagates according to Huygens.